Okay, so hyperbolas again. Part 2. Alrighty. We're just going to move the center around, and it's not going to be at the origin now. So we'll do the h and the k business. So remember, so let's say we have the orientation as left, right. You'll have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So that would be your left-right orientation. It's at the center. So the center will be h, k. In this case, it would be 0, 0. And then the vertical orientation, so y minus k quantity squared, right? Y and k always go together, over a squared minus x minus h quantity squared over b squared equals 1. So that would be your vertical orientation, like so. And so your center is still hk. All right, so that's what they look like. It won't be at the origin this time. So let's say we'll do an example. I'm going to do a several. Listen to your feedback. So we're going to graph x minus 3 quantity squared over 4 minus y plus 5 quantity squared over 9 equals 1. And then we'll also find the foci, vertices, and asymptotes. Okay, so A is 2, B is 3. We need C. We've got 4 plus 9, so C equals the square root, C equals the square root of 13. And the orientation on this is a horizontal orientation. So we know the center, let's write that down, the center is located at 3, negative 5. Right? We get it from our h and our k. And then we've got let's do vertices next. All right, so the orientation is horizontal, so I know that my y coordinate will be the same for both. My x coordinate is the one that'll change. So the x coordinate, well, if the center is at 3, let me draw another little picture over here. My center is at 3, 1, 2, 3, negative 5, 1, 2, 3, 4, 5. So the center is down here. We're going to move a units in either direction. So I start at 3. I'm going to move plus 2 and minus 2. But my y will remain negative 5. So my vertices will be at 3 plus 2, so 5, negative 5, and 3 minus 2, so 1, negative 5. Let's see, does that make sense? I'm down here at 5, negative 5, 1, 2, 3, 4, 5, negative 5. Yep, that makes sense. And 1, negative 5. Yep, that makes sense for our vertices. Our foci, let's talk foci now. Again, the y coordinate will be the same for the foci because the foci are in line with the vertices. It's just the x coordinates that will change in this case. So I've got my center is at 3, and in order to get out to the foci, I go a distance of c units. So c is square root 13, so I'm going to go plus and minus square root 13, and I will stay at negative 5 for the y coordinate. I'm not going to actually add those together. I'll just leave it as plus and minus square root 13. Or if you want to write it as two different ones, 3 plus square root 13, negative 5, and 3 minus square root 13, negative 5. Those are your foci. We need the asymptotes next. So I said this was kind of the more tedious part of the shifted hyperbolas. So first let's find our slope of our asymptotes. So if we look back here, we know that asymptotes are going to do this, right? So the rise, it's going to rise B and run A. B, A. We're going to rise B, run A. So the slope of my asymptotes, B is 3, A is 2. So the slope will be positive and negative 3/2. We are not going through the origin anymore, so we can't do the y equals mx plus b as easily. And I don't even know what the y-intercept is, just by looking at this. So I'm going to have to use point slope form. So that's y minus y1 equals m times x minus x1. Remember that one from Algebra 1? So here we go. Let's pick the positive slope. So y minus, all right, the coordinate that this asymptote will go through is always the center. So let's use center as our point. So y minus a -5 equals, we said let's pick the positive, so 3/2 times x minus, goes through the coordinate 3. So there is one of my equations for my asymptote. The other one, y minus a -5, because the other asymptote also goes to the center, so might as well use that coordinate, equals -3/2 times x minus 3. So those are both of those are the equations of your asymptotes. One is the positive slope, one is the negative slope. They both go through the center, HK. So there you go. If we're going to graph it, let's graph it nice. We've got a center at 1, 2, 3, 1, 2, 3, 4, 5, 3, -5. I should have used my little graph paper. Oh well. And then we've got an asymptote slope of 3/2. So from the center I go 1, 2, 3, run 1, 2. And so there's one of my asymptotes. And then from the center I rise 3, run -2. So here's the other asymptote. And my vertex is at 5, 1, 3, 4, 5, -5, and 1, -5. So my graph would look something like this. There we go. Okay, so let's do, if you're good with this, you can move on. If not, I'm going to do another example. I'll do a vertical orientation example. So we're going to graph y minus 4 quantities squared over 9 minus x plus 3 quantities squared over 25 equals 1. And we'll find all the parts too. So this is a vertical orientation. I'll just do a little sketch. It's going to look like this. A equals 3, B equals 5. So let's find C. 9 plus 25, so that'll be 34. So C equals the square root of 34. And so the center is located at, now be careful, this is your K, this is your H, right? H goes with X, K goes with Y. So your center is at -3, 4. All right, then we need the vertices. So the vertices, they're going to have the same X coordinate. That is my child blowing his nose very loudly. They have the same X coordinate, but different Y coordinates. So the vertices will be at -3, and then we start at the center and we move up and down 3 units because your A is 3. So the vertices will be located at -3, and then 4 plus 3, 7, and negative 3, 4 minus 3 is 1. Okay. Next, we have foci. Okay, so the foci, let's see, foci on this guy, we're going to be at same x again, so negative 3, and then the y will change, let's see, the foci will be square root 34, plus minus square root 34. You can leave it like this, or you can write it as two different ones, negative 3, 4 plus square root 34, and negative 3, 4 minus square root 34. Either way is fine. Next, we need the asymptotes. So let's take a look at that. We rise A, we run B. So the slope on the asymptotes, we're going to rise A, 3, we run 5. So plus minus 3/5 is our slope. And so let's write our equations. Let's do positive slope first. Y minus y1 in this case is 4 equals m, we'll use positive 3/5 times x minus x1. And the other one will be y minus 4 equals negative 3/5 times x plus 3. Now, I believe your book puts these in slope-intercept form. So I'll go ahead and do that on this example just to give us some practice. So let's take the positive y minus 4 equals 3/5 times x plus 3. Distribute the 3/5. And I'm going to change this to y minus 20/5 because we're all in terms of fifths. So add 20/5 to both sides, so y equals 3/5 x plus 29/5. And then the same thing for y minus 4 equals negative 3/5 x minus 9/5 if I distribute the negative 3/5. And so that'll be y minus 20/5 equals negative 3/5 x minus 9/5. So y equals negative 3/5 x. I'm going to add 20/5 to both sides. So that'll be 11/5. So on a test, I honestly don't care which form you write it in. But to match it with the back of the book, if you're trying to check your work, there you go. Okay, and then, let's graph it too. So here's our, here's our coordinate plane, and our center is at negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4. And let's see, vertices are at negative 3, 1, negative 3, 1, up 1, and negative 3, 7, 4, 5, 6, 7. All right, and then our A we've got is, sorry, we've got, where's our slope? There it is, 3/5. So if I'm at the center, I rise 1, 2, 3, run 1, 2, 3, 4, 5. You could even make a little box, right? Here's a box. You go out from the center, you go 1, 2, 3, 4, 5. And you make a little box here with the vertices. And then you go 1, 2, 3, 4, 5. So there we've gone rise 3, run 5, rise 3, run 5, rise 3, run down 3, 5, down 3, 5. So we made a box, and you can just draw your asymptotes from corner to corner on the box. That's another way of doing it. So these are going to be really wide. Whoosh. There we go. Okay. Have a great day. Talk to you later.